If you loved trig, I'm sorry, we're moving on. If you didn't like trig, we are going to do something entirely different. No. No, I can't.
Look at that. That one is so much darker.
No. Okay. So, we're going to look at two ways to create groups. The first way is called making a combination, and the second is called making a permutation. Okay? Well, you can't learn one without learning the other. So, the hardest thing you're going to do today is to choose, is it a combination or a permutation? And permutations actually can be divided into two separate ideas. So really there are three ideas we're looking at. Combinations are the smallest, and then there are two types of permutation, one bigger than the other. For somebody injured and moaning walking down the hall, no, I don't. I'd rather not. Okay, so we're going to look at three versions of a very similar story. Each one of these has one little aspect that's different from the other two, and that's how we're going to distinguish combinations and permutations, because they're nearly identical. So, first paragraph. Suppose that a student has 5 textbooks labeled 1 through 5 for school. If her backpack can only hold 2 books and she's not too injured, how many ways can she fill her backpack? There you go. I had a great spring break. I went to Albuquerque and had the best food in the world. Okay, so we're not going to worry about which book goes in the backpack first. We're just looking at if you can only take 2 books to school. So it doesn't matter which one goes through the door first. We're just measuring which 2 books can make it. So we have 5 books, and we're picking 2 of them. How are we going to figure out how many different ways this can happen? Okay, pair them up. 1 and 2, 1, 3, 1, 4, 1, 5. What about 11? Oh, good. 11 doesn't exist, and that's important. The fact that 11 doesn't exist is important. Okay, so that's all my book 1s. So what about 2, 1? That doesn't exist. How come? Because it's 12. Okay, so 2, what about 2, 2? No 2 2s? Good. 2, 4, 2, 5. 3, 4. 3, 5. 4, 5. What about 5? No, we can't use 5. All right, so the important things here, 11 doesn't exist, and, oh, there are 10 answers, by the way. And in this case, 12 is equal to 21. 12 and 21 are the same number. Because as long as book 1 and book 2 make it to school, we don't care how they got there, we don't care what order they showed up in, 12 and 21 are the same number. This is called a combination. So down on combination, I want you to write 12 equals 21, and I also want you to write that 11 doesn't exist. Okay? Let's change the story slightly. Same numbers, same number of digits. There are 5 marbles in a bag labeled 1 through 5. How many different ways can you pull out 2 marbles and arrange them to create 2-digit numbers? Let's make the list. What about 11? Can I arrange 2 marbles and make an 11? No, why not? I only have 1 of each marble, so that doesn't exist. Okay? So 12, 13, 14, 15. for my next column? 21. Wait a minute. 21 and 12 are the same thing. Right. This time I'm arranging them. I'm ordering them. So 12 does not equal 21. That's called a permutation. So down under permutation, 12 does not equal 21. So for a combination, there is no order. And on a permutation, you probably want to write, doesn't start with an N, order matters. On a permutation, 12 and 21 are counted twice. No, combination is no order. Permutation, order matters. So if you, that is pretty obvious why permutations are bigger than combinations. Because there are so many cases where 12 and 21 come up. So permutations have to be bigger than combinations. But there's more to it than that. Okay, so let's finish this list. What about 22? Does it exist? No. So 23, 24, and 25. But I'm lazy. There's 4 in the first column and 4 in the second column. How many will be in all the other columns? 4. How many columns are there? There's a 1, 2, a 3, a 4, and a 5 column. So 5 times 4 is 20. So there are 20 ways to create 2-digit numbers using 5 digits. Okay? Paragraph 3. If there are 5 marbles in a bag labeled 1 through 5, how many 2-digit numbers can be created, using the following model? Reach into the bag, take out a marble, write down the number on a piece of paper and place the marble back in the bag. Draw a second marble out of the bag and write the number down to complete the 2-digit number. How does that change our list? Right now, so I'm going to use this same list, but 11, 22, 33, 44, and 55 all of a sudden exist. So how many ways are there to complete this? 25. So this is 25. So permutations can be divided into 2 categories. Now I can show you. So the first is without replacement, which means there is no 11. Unless, in fact, there are 2 1s in the bag, but that makes things incredibly complicated, so we're not going to do that. And just so you know, probability and I don't really get along. My brain doesn't work that way. So I can handle all the stuff that I'm going to teach you, but when it gets complicated, I just throw in the towel. I don't know how to do it. Okay, with replacement, 11 exists. And it exists because you put the marbles back in the bag. You replace the marbles. So combinations, there's no order. Permutations, there is an order, but there are 2 types of permutations. One, you put the marbles back, and you can have duplicates, and the other one you can't. So, for combinations, there's a button on your calculator called NCR. Don't look for it. You're not going to find it. Okay? You can write out the list of combinations, and usually you can find a pattern, and you just continue the pattern and then add them all up. But that takes too much time. So I'm going to show you how the calculator calculates them. And there is a fancy formula on how to do it. I'm not even going to bother showing it to you. You don't need it. But let's just think of it. N is the total number of things you're looking at. And R is the number chosen. So this first box, 5C0, if you have 5 books, how many ways are there to put none of them in the backpack? 1 way. You leave them all out. So 5C0 is actually 1. So 5C1, and sometimes we write it this way, 5 like this. That's really common for combinations. And we say 5 choose 0. And you're going to hear me say that. 5 choose 0 just means 5C0. And it only deals with combinations. Um, so 5 choose 1 means you have 5 books. How many ways are there to put one of them in the backpack? 5 ways. You put them in one at a time. We already calculated 5C2. That was 10. What do you think 5C3 is going to be? 15? Why? Well, a pattern I see a multiply by 5 and a times 2, or an add 4 and an add 5. People always say 15, but I don't get how they get that. Anyway, whatever. You're all wrong. So, to use the button, you do your n value first. So push 5. And then push math. And all the way to the right is a probability column. If you go all the way to the right, it's number 3. 5C3 is 10. That doesn't make any sense. It does? How come? But wait a minute. Why is putting 2 books in the same as putting 3 books in? Why? Wouldn't you think the more books you use, the more there should be, right? Okay. Well, let's not explain that. It'll make sense here in a minute. What is 5C4? Whoa, we're going down. So this is 5. What is 5 choose 5? Now, this one makes a lot of sense. Why? If you have 5 books, how many ways are there to put all 5 of them in the backpack? 1. You put them all in. What about 5 choose 6? Don't type it in. It's not error. If you have a backpack that holds 5 books, how many ways are there to put 6 books in there? None. 5 choose 6 is 0. Because you don't have enough room for those books. Okay? Well, this makes sense. If we can understand 5 choose 4, then we can understand 5 choose 3. Why are there only 5 ways to put 4 books in? Well, let's make the list. What are the 5 ways? 1, 2, 3, 4. 2, 3, 4, 5. 1, 2, 3, 5. 1, 3, 4, 5. Which one are we missing? It's got to be a 1. 1. 1, 2, 4, 5. There it is. Okay. Do you notice anything interesting about this list? Well, one of them is missing a 1, right? This one is missing a 1. This is missing a 5, a 4, a 2, and a 3. No. So, why are these 2 the same? So look at this list. Why are 5 choose 1 and 5 choose 4 the same number? Well, how many ways are there to put 1 book in? 5. How many ways are there to leave 1 book out? 5. So the input matches the output, right? So how come 5 choose 2 and 5 choose 3 are the same number? So putting in 2 is the same as leaving out 2. So 10 choose 3 is exactly the same thing as 10 choose 3 is equal to 10 choose 7. Yes, and I'm trying to explain why, what you're talking. Right, because if two R values add up to be an N value, then the total number of options is going to be the same. Because putting 3 books in the backpack is the same as leaving 7 books out. So combinations always build that way. So the N's are always going to be 1s, and then as you work in, the numbers are going to match. And if they're an odd number of numbers, then there'll be a center, like these aren't real numbers, but 1, 6, 12, 18, 12, 6, 1. Because there's an odd number, so there's actually a middle. So this would be, anyways. No. So we had 1, 5, 10, 10, 5, 1. Right. Yeah. So if you had 9C 5, there would not be a middle number because it's a 9. But if it was 10, 10C something, then there would be a center number. But yeah, that pattern is always going to follow. That's not true with permutations. Permutations grow, mostly. Okay, so permutations can be done with the NPR button, which is not National Public Radio, but whatever. Let's do a couple of these in our head. 5P0. We're creating a 0-digit number with using 5 marbles. You would think 0, right? But that's a problem, because we've said for a long time that 4 to the 0 equals 1, and we just agreed that that's true. And because that's true, this is actually 1. Just trust me on that. But it makes sense, because let me introduce you to a number we rarely use. The empty set. The empty set is the set of numbers with nothing in it. So how many ways are there to create a nothing number using 5 digits? 1, you don't do anything. So it's 1. And just so you know, that's also going to be a 1. They don't make as much sense as the backpack story, but whatever. Okay, how many 1-digit numbers can we create using 5 digits? 5. And we already calculated 5P2. No, skipped it. It was 20. Okay. 5P3. Use your calculator and don't go ahead. Calculate 5P3. We expect it to go up 60. Okay, don't go ahead. I know some of you want to. I'll hurt your other shoulder. Oh, wait. They're both bad. Okay, so this makes sense. Do you see a pattern? It's growing. Okay. Calculate 5P4. 120. Okay. Wait. I want you to guess. Clever. Now, would we expect the last one to be bigger, smaller, or stay the same? Calculate 5P5. 120. Now, Landon has to be quiet because he found the pattern. Now, let me put this into context. I give you a bag of 5 marbles, and I say, I'm going to tell you how many marbles to pull out, and you're going to write down that number. If I tell you to pull out 4 marbles, you will get the same amount of numbers as you will if you pull all 5 marbles out. Isn't that weird? If you create a 4-digit number, there are 120 options. If you create a 5-digit number, there's still 120 options. Why is that? Actually, it makes perfect sense. Let's leave numbers behind. Okay. Peyton, pick one of those letters. E. Colette. Bo. Okay, apparently Bo. Yeah, you missed it. You missed. Okay, so what happens when I pick the next letter?
You're going to get a bigger letter word.
Well, not only do the possibilities get smaller, when I pick the next letter, the possibilities are gone, right?
2A.
If I pick A, do I get to pick D?
Yeah.
No, it's chosen for me. So when I pick the second to last letter, I also pick the last letter. So if I did this, do I even need that? No, it has to be an E. I don't get to choose. Or D, sorry. Call me Bo. I don't follow instructions very well. So with permutations, and again, this is permutations without replacement. I'm not allowed to duplicate. Once you pick the second to last letter, you pick the last letter automatically. Okay? So let's figure out how many options there actually are. Well, I could do 5p5, right? Using my calculator, or I don't have to. I know there are 5 digits. How many options are there for the first digit? 5 options. I'm holding the bag of marbles. There are 5 marbles in the bag. So the first digit has, well, if you're only creating a 1-digit number, you get to pick 1 marble. So there are 5 options. Okay? Now notice, this matches that. And this is, Landon figured out the pattern a long time ago. Okay? Well, how many options are there for digit 2? There's only 4 options. How come? Because one of them is already out, and I'm not allowed to put it back in. Right? This is without replacement. So the second digit, there are 4 options. Well, what do you notice about that? 5 times 4 is 20. So you can use the calculator if you want. Yeah, we'll get there. So you can use the NPR button, or you can just line up the number of digits you need and then figure out how many go in each place. So once I've chosen the first marble and the second marble, how many options are there for marble 3? 3 options, and 5 times 4 times 3 happens to be 60. Well, how many for marble number 4? 2. And 5 times 4 times 3 times 2 is 120. Well, once I've chosen the second to last marble, how many options are there for the 5th marble? There's only 1. Whether or not I pick it, it's the only one left. This formula works for this level every time. But it also sort of works for the next level. Right. Let's say that instead of writing down the marble or just setting the marble down, what if I put the marble back in? So it's still a permutation. So 12 and 21 are still separate. But down here, I line up 5 spaces. How many for marble number 1? 5. So this is 5. How many for marble number 2? 5. And we already decided that this was 25, right? That was story number 3. Well, what about for 3 digits? 5. What about 4 digits? Because I'm putting the marbles back in. I pick it out, read it off, throw it back in. Then I have 5 to choose from every time. And, oh, this is, sorry. 125. No wonder you guys are so confused. 625, and if I throw another 5 up there, 3125. Do I have to stop at 5? How big could this number be? Could I keep putting spaces? I could. I only have 5 marbles, but I'm putting it back in every time. Right, this goes to infinity, right? What about 5p6? Type that into your calculator. Try it. 5p6. 0. How many 6-digit numbers can you create with 5 marbles if you're not allowed to duplicate? None. It just can't happen. You have more spaces than you have marbles. So combinations start at 1 and end at 1. Permutations without replacement start at 1 and they end where the last one and the second to last one are the same number every time. So if I were to calculate 60p59, that's going to be equal to 60p60, whatever it is. But permutations with replacement, there's no limit to the number of digits you have because you're always putting those marbles back in and you're allowed duplicates. So combinations are the smallest set, then permutations without, and then permutations with. Okay? So this formula down here, so if I had 4 spaces, 5 times 5 times 5 times 5, that's just 5 to the 4th. So the formula is just n raised to the r. The number of marbles in the bag raised to the number of times you're going to pull marbles out of the bag. 5 is the number of marbles in the bag, and r is the number of times you pull marbles out. Well, it would change. Well, let's do some examples. Look at the next page. So, the easy part is identifying n and r. The hard part is deciding, does 11 exist, and does 12 equal 21? If you can answer those 2 questions, then you just have to use the correct formula and plug in n and r. Well, sometimes it does, sometimes it doesn't. Right. So when you put the marble back in, 11 exists. And if 12 and 21 are the same number, it's a combination. If 12 and 21 are different, it's permutation. Hang on, we'll get there. I've got you all confused. Number 1. There are 10 people at a party. Each pair of people shake hands exactly once. How many handshakes were there? So, in this case, n equals, there are 10 people. What is r? No. So r is the number used in any event. How many people are being used at one time? 2. A handshake involves 2 people. It doesn't matter. How many total handshakes? No. Okay, so let's think about this. Does 11 exist? No, why not? You can't shake your own hand unless you had 2 right arms. No, it doesn't count. Oh, so if I shake Colette's hand, is that any different than Colette shaking my hand? So I'm person number 1, of course, and Colette is person number 2, of course. If you know what I mean. So are 12 and 21 the same number? Yes. Does everybody understand that? But it's the same thing. If you think that's the same thing, you're going to do really poorly on the test. So 12 and 21 are equal. What? Yes. Oh, N apostrophe T. Let me, so, yes. So, 12 and 21 are the same number. Everybody agree? Okay. Whatever I said to confuse you, just delete it from your memory. So, if these are the same thing, that means it's a... Good job. Combination. That's it right there. If 12... Okay, I'm person 1, you're person 2. Wait. Wait. Shh. If I shake your hand and you shake my hand, is that two different things or is that the same thing? It's the same thing. Therefore, it's a combination. Yes. So we use 10C2. That's the answer. Yes. Okay. What is that? 45? All right. Let's see if I can confuse you again. Number 2. Jim has 6 books. 10C2. 45. Jim has 6 books in his backpack. Math, English, science, history, Spanish, sociology. How many different ways are there to arrange the 4 books, 4 of the 6 books on the shelves? So, N is 6, R is 4. Well, let's decide. Does 12 equal 21? So if I put book 1 and then book 2, or I put book 2 and then book 1, are those different arrangements? They're different, and if you disagree, go talk to the librarian. She wouldn't be happy, right, if you went and rearranged all her books? It might be funny. So, but wait, we're not done. If it's a permutation, we have to ask another question. Right? There are 2 different types of permutations. So we need to ask, does 11 exist? Right, 11 does not exist, which means it's without replacement, which means we can do 6p4. It is a big number. The other way to calculate this, if you don't want to use the NPR button, whenever there's a permutation, you just have to write out R spaces. How many options for space 1? 6. How many for space 2? 5, because 1 is already there. So 5, 4. Right. So that's 30, 120, 360. Either way, you should get 360. P is permutation. Well, you have to look at the story. The story tells you. So, if you're shaking hands, if I shake your hand or if you shake mine, that's the same thing. If you're putting books on the shelf, book 1 then book 2 is different than book 2 and then book 1. But if you're taking books to school, if you take 2 books to school, it doesn't matter which one you took first. The story tells you whether order matters or not. Because if you put the marbles back in the bag, then you might pick 1 the first time and 1 the second time. Yeah. Well, if 11 exists, you can't use this button. No. I'll show you when we get there. Okay, number 3. Suppose there are 12 people in a room. How many groups of 4 people can be created?
So n equals 12.
N is 12. And R equals 4. So, if 1 and 2 are in a group, is that different than 2 and 1 being in a group? So, 12 equals 21, so 12C4. Four people, right. 4 people in a group. Put it right there. So, how could we change this so it was a permutation? Good. So if I said, you're the first partner, you're the second partner, third partner, fourth partner, that would turn it into a permutation. Because the first partner has to write, and the second partner gets to sleep, and the third partner gets an F.
Second partner.
So, just because you're picked in a group does not mean combinations. If you have specific jobs to do, that would be a permutation. If you don't, that's a combination. Okay? If you're lining up, that's a permutation. Okay? Yes. If you're in a line, that's a permutation. If I said 2 of you get to go home early, that would be a combination. Right? Because you don't really care which one of you leaves the door first. You both get to go. But if I say you get to leave 10 minutes early and you get to leave 5 minutes early, that would be a permutation. Because the 5-minute person would rather be the 10-minute. Number 4. There are 10 students to be lined up for lunch. How many lines can the entire class form? So 10 kids in class. N is 10. And R is... What is R? Only one person? 10. There are 10 people in class and all 10 of them get to line up. Well, if it was C, then the answer would be 1, right? How many ways can the whole class go to lunch? 1. But how many ways can 10 people line up? So this is a permutation. Is it a permutation with or without replacement? Without. How come? Darn it. Can't clone a kid. So you're either going to do 10p10, or what's the other way to calculate this? 10 times 9 times 8 times 7, all the way down. Here's a random question. 10p10 is equal to 10p9. So here's a strange thought. If everybody gets to line up and go to lunch, that's the same number of ways as everybody except one gets to line up and go to lunch. Whether or not that last person goes does not affect the total number of choices. Yeah. You're not needed. What's the number? It's something big. Yeah. Okay. Number 5. Shh. Hey, we need to get through this. 10 tennis players are entered in a tournament. How many ways can the 1st through 5th players be ranked? Combination or permutation? No, we're using 1 through 100, but we have 5 spaces. Permutation, how come? Because 1, 2, 3, 4, 5 is different than 5, 4, 3, 2, 1. So let's do it this way. How many options are there for first place? 100. How many options are there for the second space? For the third space? And that's the same as 100p5. It's big. I'm not going to write it down. You guys have to. There. R is 5. Yeah. Yep. Okay, number 6. So, when I was in high school, Carbon School District got a new superintendent, and they were interviewing him on the radio, and they said, "What are you going to do different now that you're the superintendent?" He says, "We're not changing anything. There's still 23 letters in the alphabet. We're going to do things just like we did before." Just so you know, there are 26 letters in the alphabet. Okay, number 6. If a license plate contains 4 digits and each digit can be one of the letters of the alphabet, how many different license plates can be created? So N is 26 and R is 4. So we have 4 spaces. Combination or permutation? Permutation. Why? Because if Bo went and got a vanity license plate with his name on it, and it came out like this, he would be really upset, right? So, does Bo equal Ube? No. Therefore, it's a permutation. Now we have to decide, does 11 exist? Yes. How come? If you wanted to have a license plate like that, does that license plate exist? Yes. So, how many options are there for letter 1? 26 times 26 times 26 times 26, 26 to the 4th. N to the R is the formula. Okay. Number 7. I don't know. 26 to the 4th.
4, 5, 6, 9, 10.
There you go. Big number. Just type in 26 to the 4th. Type in 26 to the 4th. Okay. A bookshelf contains 3 math, 3 science, 3 social studies. And the key here is if all of the books are different, so there's like an algebra, a trig, and a statistics, how many ways can the books be arranged on the shelf? Combination or permutation? Permutation. So N equals 9 and R equals 9. Are we allowed to replace? No. So it's going to be 9p9, which is the same as 9p8, whatever that is. Your assignment is to finish this worksheet. Have fun.